In this video, I want to have a look at solving simultaneous equations, and we're specifically going to look at it using the elimination method. So in other videos, we've looked at solving them graphically, and we've looked at solving them using the substitution method. This one's specifically elimination method. In our first example, we've got two equations. One of them is 3x minus 5y equals 23, and the other is 4x plus 5y equals 19. So the elimination method works really well when one of the variables has the same coefficient in both equations. So in this case, our y's are both 5y's. One of them's negative and one of them is positive, but that's okay as long as they both have that 5. So we're going to start off by numbering them equations 1 and equations 2. Now what we're going to do is we're going to eliminate one of the variables, so either the x's or the y's. In this case, because it's the y's that have the same coefficient, they're the ones we're going to get rid of. And to do that, in this example, we're going to add these two equations together. We're going to go equation 1 plus equation 2. So that means we're going to have 3x plus 4x would give us 7x. Minus 5y plus 5y would give us 0. So they're gone, they're eliminated, which is what we wanted. And 23 plus 19 will give us 42. So now we've got 7x equals 42. So to figure out what x is, we're going to divide both sides by 7, and we'll end up with x is equal to 6. So that's half our answer. We know what x is. Now we need to figure out what y is. So to do that, we're going to substitute back into one of these equations. It doesn't really matter which one you do. Let's sub into equation 2. Sometimes ones with addition in them are a little bit nicer. So we're going to have 4x, but x is 6, so it's going to be 4 times 6. Plus 5y is equal to 19. So 4, 6 is 24, plus 5y is equal to 19. So we'll subtract 24 from both sides. We'll end up with 5y is equal to minus 5. And then divide both sides by 5, we'd end up with y is equal to minus 1. So our solution is x equals 6, y equals minus 1. It's always a really good idea to double check your answers to those by substituting back into the equation. Our second example, we've got the equations 2x plus 3y is equal to 12 and 2x plus 7y is equal to 36. So again, we'll always start by numbering our equations, equation 1 and equation 2. So if we have a look at them, this time it's going to be our x's that we eliminate because they both have the same coefficient this time. If we do what we did in the first example though, if we were to add those two equations together, we'd have 2x plus 2x, which would end up with 4x. So what we're going to have to do instead is subtract the two. So if we go equation 1 minus equation 2, we're going to have 2x minus 2x will give us 0, which is what we wanted. 3y minus 7y will give us minus 4y. And 12 minus 36 would give us minus 24. So then to get the y on its own, we'd divide both sides by negative 4. And we'd end up with y is equal to 6. So that's the first half of our answer. Now we're going to substitute that into either of our equations up the top. Doesn't really matter, let's substitute it in 1 because it's got smaller numbers. So sub into 1. So we're going to have 2x plus 3y, but y is 6, so it's going to be 3 times 6 is equal to 12. So 2x plus 3 sixes are 18 is equal to 12. So subtract 18 from both sides, and we'll end up with 2x is equal to minus 6. So x will come out to give us minus 3 if we divide both sides. So our final answer is x equals minus 3, y equals 6. All right, so that's two examples of how we can use the elimination method to solve simultaneous equations.